When you're talking about one of the largest machines humans have ever built, some of the biggest challenges are actually the simplest ones. Like, how do you make it stop? Today, we're going to dive into the incredible engineering behind controlling a massive aircraft carrier, from its anchor deep in the sea to the jets landing on its deck. So let's just start with a number to get a sense of scale. 100,000. That's how many tons a modern aircraft carrier weighs. It's basically a floating city made of steel, and, well, trying to control that kind of momentum is a monumental task. So that really is the big question, isn't it? How on earth do you bring 100,000 tons of sovereign territory to a dead stop in the middle of the ocean? And then, how do you stop a 150-mile-per-hour fighter jet on a runway that's less than 1,000 feet long? The solutions involve two very different but equally incredible feats of engineering. So here's what we're going to cover. We'll start by looking at how you stop the ship itself. Then we're going to zoom right in on the anatomy of that powerful anchor system. After that, we'll head up to the flight deck and see how they catch a screaming fighter jet. And finally, we'll get to the mission-critical checkup that's so important to both, and you'll see the one thing they absolutely have in common. All right, let's jump right in, stopping the 100,000-ton ship. Look, before any jet can land or take off, this floating city has to be held firmly in place, fighting against wind and tide. And for centuries, the main tool for that job has always been the anchor. The concept itself is pretty simple, right? You just tether the ship to the seafloor to keep it from drifting. But when the ship is this big, that simple idea requires some absolutely mind-boggling hardware. Hardware that has to work perfectly every single time, no exceptions. So let's take a closer look at the anatomy of that anchor. It's easy to just picture a giant piece of metal being tossed overboard, but the reality is way more complex. It's a powerful machine that spans several decks deep inside the ship, and it's all managed by a highly trained crew. Okay, now check out these numbers. The anchor alone weighs 30,000 pounds. We're talking the weight of two full-grown elephants. And the chain? It stretches for nearly 1,500 feet. The sheer scale of this stuff is just incredible. Now, controlling all that weight requires some really specialized machinery. The windlass is basically the giant, powerful winch that does all the heavy lifting. And on that winch, you have these special drums called wildcats. They're amazing. They're designed to perfectly grip each individual chain link, but, and this is crucial, they also act as the brakes. This whole system is housed deep inside the ship. Way down below, you've got the chain locker, which is exactly what it sounds like, a massive room just to store all that chain. And that connects all the way up through a shaft to the windlass room at the very front of the ship, which is where all the action happens. And you better believe, with stakes this high, failure is just not an option. So this system is tested relentlessly. The anchor drop test you see here is this really carefully choreographed procedure. They'll do a controlled drop first, then a full-on freefall test, disengaging the brakes completely and then just slamming them on to prove they can stop all that immense weight on a dime. Okay, so we've stopped the ship in the water. Now let's talk about stopping a jet on the water. We're heading up to the flight deck. Here, the challenge is completely different. We're talking about catching a fighter jet moving at 150 miles per hour. The speeds are way higher, and the margins for error are razor thin. I mean, here's the fundamental problem, right? A fighter jet, when it's landing at over 150 miles an hour, it needs thousands of feet of runway to stop safely. On an aircraft carrier, you've got just a few hundred feet. So the solution? Well, you have to literally catch it. The whole process is just a violent, controlled chaos. As the jet touches down, a tailhook on the back of the plane snags one of several steel cables stretched across the deck. That cable gets yanked forward, spooling out from this massive hydraulic engine below that absorbs all of the plane's incredible momentum, bringing it from 150 miles per hour to a dead stop in about 2 seconds. It's wild. But what's really fascinating is that this naval technology isn't just confined to the sea. The U.S. Air Force actually uses a very similar system on land, but for a totally different reason. So the crucial point here is the difference in purpose. On a carrier, using the arresting gear is just business as usual. It's for every single landing. But the land-based version, which is called the BAY K-12, that's an emergency system. It's there for when a pilot has a major problem in the air. But both systems demand absolute perfection when they're called upon. So we have these two incredible stopping systems, one for a 100,000-ton ship, another for a 150-mile-per-hour jet. One uses gravity and friction, the other uses hydraulics and steel cables. I mean, they seem worlds apart, right?
But as we're about to see, they are connected by a single, vital, human principle.
This quote about the land-based arresting gear, it really says it all. These systems are all about safety. They are the last line of defense, and whether they work or not is a matter of life and death. And that reliability doesn't just come from a factory. It's earned through constant, diligent maintenance. Think about that 30,000-pound anchor again for a second. Every single time it's dropped and hoisted, the chain is getting beat up by friction and stress. It's constantly sitting in corrosive salt water. A single cracked link or a loose pin could cause the entire system to fail, putting the whole ship in jeopardy. And that's the connection. It doesn't matter if it's the anchor chain being laid out on a dog for a link-by-link inspection, or technicians meticulously checking the arresting cable for any tiny phrase. Both of these systems are completely dependent on meticulous human oversight.
So the ultimate takeaway is really this. The most important component in these incredible feats of engineering isn't the high-strength steel or the powerful hydraulics, it's the people. It's the crew members who check every single link, test every break, and make sure these systems are ready to do their life-saving work every single time.
It really makes you think, doesn't it? What other amazing tech in our lives relies not just on a brilliant design, but on the hidden, tireless work of the people who check the links, test the brakes, and ensure our safety behind the scenes? Something to chew on. I hope you enjoyed this look at controlling the colossal.